So we're looking at 15.4 AS Pure Mathematics Integration, and this is applying definite integration in order to find areas. So you might want to just have a look back at 15.3 and make sure you understand how to do definite integration. That's where you've got limits and therefore you end up with a definite answer rather than an algebraic answer. And we're going to be applying it to this situation here. So if you are working out the integral between a and b, the lower limit matches up to the lower limit on the graph and the upper limit is matching up to this value. It will give me the area from those two values between the x-axis and the curve. Okay, so it always goes to the x-axis because I'm working with respect to x there. So if we have a look at the first example, so 15.4.1, so I have been asked to find this shaded area. So to set that up, I'm using the integral sign. The curve is x cubed. With respect to x, try and get this notation correct. My lower limit is 1 and my upper limit is 2. So remember, to integrate, we add 1 to the power and divide by it. Then I put the two limits on just so that I know where I'm up to in my working out. Substituting the upper limit in first, so that is 16 over 4. And then the lower limit in second. And then we subtract. So that gives me 15 over 4 units squared because it's an area. You can use this button on your calculator, but just be aware that if you just put it into your calculator in an exam situation, then you won't get any marks for it, but you can use it to check. Now, the question will require some method to be shown, and we recommend showing all of this working out that we've got here, including the subtraction. So put the upper limit in and then the lower limit in and subtract the two on the same line. Don't start making it up into little, like cutting it around your page, because that piece of working out there generally gets a mark for being able to apply definite integration. Let's have a look at 4.2. So if we were to integrate, it's the same function, and I'm going, my lower limit is -2 and my upper is -1. So we're doing the same function, which is x to the power 4 over 4 between -1 and -2. And when I put this in, remember when you do to the power of 4 on a negative, you will get a positive number. So we end up with this. Now, those of you that were paying attention above will have seen that written in the notes. So because definite integration has more than one application, you can get a negative definite integral, but you cannot get a negative area. So it's this section here. When the area is below the x-axis, you need to be careful because your answer will come out as negative. And obviously I can't work with a negative area. So you need to remember that and you need to spot it. In terms of the working out, you do what we have just done here, but then you would just sign off and say, therefore, the area is equal to 15 over 4 units squared. Okay, so just be careful. You can't have a negative area, but you can have a negative definite integral. So those of you that are switched on, having a look at 4.3, what would be the problem with integrating between -2 and 2 here? So just have a look at its symmetry. You should be able to just give me that answer. So if we were to do this calculation, we would get an answer of 0 because of the symmetry of the graph. This area here between -2 and 0 is the same as between 0 and 2, and therefore they will cancel out. Now, if you get a question like that and you've forgotten about the negative area, it's obvious to spot now because you can see, well, I can't have an area of 0 because I can see 1, therefore I must have gone wrong somewhere, and that will prompt you. The problem comes if we did say the area from -1 to 2, where these two areas are not equal, because you will still get an answer out then and it will still be positive because this area is slightly smaller, but it won't be right. So do watch for that. Okay, so you can't do that. We need to split them. So that is just wrong. Okay, because of that negative area. So if we label this up A and B, I'm going to do the integral for part A. Now be careful here. So it's -2 and it's going all the way through. So it changes. We have we're crossing the axes at 0. So we're going to take all of that. So it's not just the answers that we had above. So if we put those into our brackets, we are going to get 0 -4 for area A. Therefore, the total area, so area B, when we integrate between, that will be between 0 and 2, we would be expecting, and take a shortcut there and just say, well, I know that they're the same. If you're unsure, you can just check on your calculator. So therefore, the area is equal to 4 add 4, which is equal to 8 units squared. Moving on to 15.4.4. So it'd be a good idea to pause the video now and have a go at this question. You've got a few things to do. The first one is to sketch the graph, because by sketching the graph, you can see which area it is that you want to work out. And then you need to integrate it and then apply the limits. Okay, so pause the video, have a go at this question. Sketching this graph, you should have worked out that you've got a cubic and it's a positive cubic, so it will take that shape, and the roots are at -1, 1 and -2. So if I get myself a graph drawn that represents that, remember it's just needs to be a sketch, but make it big enough so that you can see what you're doing. So I'm going through -2, -1 and 1, obviously not drawn to scale, but unimportant for this. And I want to find the area trapped between the curve and the x-axis. So that's this area here, which we'll call area A, and it's this area here, which we'll call area B. Now, you will hopefully remember that in order to integrate or differentiate, these brackets need to be expanded. So before I do that, I'm going to expand this out. So I'm going to focus on the first two brackets first, and I've spotted that I've got a difference of 2 squares, which speeds me up a little bit. And then if I expand that out, so we've got x cubed plus 2x squared minus x minus 2. So that's the function that I need to integrate. So if we have a look at A, first of all, that is the integral between lower limit is -2, upper limit is -1. That's where it's crossing the axes in this question. Okay, and then we're going to integrate x cubed plus 2x squared minus x minus 2, which goes add 1 to the power, divide by new power, add 1 to the power, so 3, divide by new power, add 1 to the power, divide by new power, add 1 to the power. Don't need the plus c like we would do in indefinite integration because we've got these limits to put in. So I'm going to substitute in the -1 first. So when I put -1 in, I'm going to get a quarter minus 2 over 3 minus a half plus 2. That's the lower limit. I'm now going to substitute the -2 in. So we get 4 minus 16 over 3 minus 2 plus 4. So this working out is a good line of working out to show. So we get 13 over 12. I'm going to use this as a shortcut in a minute, so it's a good idea to write down this working out. So area A is 5 over 12. It's come out as positive, which was expected because it's above the axes. Let's have a look at area B. I'm just going to draw a line down here. So when we're doing area B, we are doing the integral between -1 and 1 of this function. And we've already integrated it here. And I know that my limits are -1 and 1. So I'm going to jump to substituting it in. Now we know that when we put -1 into here, I've got 13 over 2. So all I need to do is focus on putting the 1 in, and then I can get the -1 from the 13/2. So I've got, when I put 1 in, I've got 1/4 plus 2/3 minus 1/2 minus 2. So that's the 1 in. And then for the -1, I've got 13/12. As long as you're sure you're working out really clearly, then that is fine. Don't take shortcuts unless it's really obvious what you are doing. So for that area, I get -8/3. So the total area is equal to 5/12 plus 8/3, which is 37/12 units squared.